Have you ever wondered why a ball keeps rolling until it hits something, or why we feel pushed back when a car suddenly speeds up? All of those things happen because of something called the laws of motion. So before we dive into the laws of motion, let's talk a bit about the man behind it all, Sir Isaac Newton. Newton was an English scientist and mathematician who lived way back in the 1600s. He was super curious about how the world works, like why apples fall from trees or why the moon doesn't just fall straight down to earth. Legend has it that one day an apple fell from a tree while Newton was thinking, and that simple moment sparked one of the biggest discoveries in science history, the concept of gravity and the laws of motion. But here's the cool part. Newton didn't just stop asking why does it fall. He went deeper and tried to understand how objects move and what makes them speed up or slow down, and what keeps them in motion or at rest. After years of studying and experimenting, he summarized everything into three simple laws, the laws of motion. That explains nearly every movement in the universe, from the tiniest rolling marble to the biggest rocket blasting into space. They all follow Newton's laws. And guess what? These laws aren't just science stuff. They're happening all around us every single day. So now that we know a bit about Newton's and why his discovery matters, let's break down his first law, the law of inertia.
The law of inertia, or Newton's first law of motion, states that an object at rest will remain at rest, and an object in motion will stay in motion, unless an external force is applied upon it. For example, a ball that is at rest will remain at rest unless you move it. And when you move the ball, it will keep moving unless an external force is applied to stop it.
The second law of motion, also known as Newton's second law, states that the acceleration of an object depends on the force applied to it and its mass. For example, when a person kicks an empty gallon, it moves quickly because it has a small mass. But if the gallon were filled with water, it would move slower even with the same kick. This shows that greater force causes greater acceleration, and heavier objects need more force to move.
When you throw a basketball against a wall, Newton's third law of motion also applies for every action. There is an equal and opposite reaction. So here's what happens. When the basketball hits the wall, it applies a force on the wall. The wall then pushes back on the basketball with an equal and opposite force. Because of this reaction force, the basketball bounces back towards you instead of passing through the wall. So the harder you throw the ball at the wall, the stronger the wall pushes it back, making it bounce off faster.
In conclusion, Sir Isaac Newton's law of motion laid the foundation for classical mechanics, describing how objects move and respond to the forces. The three laws, inertia, forces and acceleration, and action and reaction, are fundamental principles that govern the behavior of objects, understanding of the universe, and influencing countless scientific and technological advancements.